Okay folks, welcome to lecture 3 of unit 5, and today we'll be looking at some ions and isotopes and variations of our atomic structure. So why don't we get started here right away and looking at ions and isotopes. Well, first thing I want to do is a quick review, and we want to review what our subatomic particles are, and we have 3 of them. We have protons and neutrons contained in the nucleus. Protons contribute a +1 or 1+ charge. Neutrons are electrically neutral, which means they have a 0 charge, and we know that electrons have a -1 charge or a 1- charge, so that when we go to find the structure in a neutral atom where the charge is equal to 0, that means the positives and negatives have balanced each other out. The atomic number, or the address of the element, which is unique for every element, is the number of protons. So essentially we can say every element has its own unique number of protons. The protons and the electrons, because the protons are positive, the electrons are negative, and we want a collective charge of 0, that means those two things need to be equal. The positive charge needs to balance out the negative charge. And the way we find our neutrons is we take our mass number, which is again the sum of the protons and the neutrons. We find that by taking our atomic mass found on our periodic table and rounding it to the nearest whole number, and subtracting the atomic number, which is the number of protons, to get the number of neutrons. So hopefully by now you have a good idea of how that works, and if you don't, go back and review your notes and go back and look at the last lecture. But now we're going to move on to our next type of atom, and we're going to be looking at an ion. And what is an ion? It is essentially an atom with a charge. So what that means is we've gained or lost electrons to gain that charge or lose that charge. Please keep in mind, we do not want to change the number of protons because that is unique for every element. That's the address of the element. That is its identity. Now, in an ion, the charge is not equal to 0. So that means that the protons and the electrons are going to be in different amounts. But we have to think of it a little backwards here, because when we gain electrons, we actually gain more of a negative charge. Remember that electrons are negatively charged, and every time I gain an electron in my structure and I add more and more electrons to an atom, it becomes more negatively recharged or negatively charged. And we commonly refer to this as an anion. If we lose electrons, which means now we have less electrons than protons, we're going to have a positive charge. So every time I lose an electron, I become more and more less, I have more and more less electrons, and this kind of ion is called a cation. And the way that we represent these are the symbols with the charge. Now there's two ways that you may see it. One way is you'll see Ca+2, which means we have the calcium ion with a +2 charge. You may also see it written as Ca2+, and that will be written on the upper right hand corner, what we refer to as our superscript, and that will tell us what our charge is. Chlorine, here's a negative charge, a negative ion or an anion, and we have it as chlorine -1 or chlorine 1-. So any one of those two ways I can represent the charge. Now the question is, how do I get those charges? How does the structure change from a neutral atom to an ion? So you'll see in your next slide that you have a blank slide. So why don't we take a look at these two examples, all right, to use as something to work with. So the first thing we want to remember here is that when we make these ions, it's these ions that enable atoms to combine to form what we call ionic compounds, and that's something that we're going to be looking at here in the next chapter. So let's take a look here at our example. So the first one we had was calcium, which was +2. Now if we looked at calcium as a neutral atom, we know that calcium has an atomic number, and the way we want to look at our atomic number here is to look on our periodic table to find out exactly what it may be. So we would see that calcium would have an atomic number, and excuse me for one moment, and it's going to have an atomic number of 20. So that means that if it has an atomic number of 20, that means that we are going to have in our structure 20 protons, which have a positive charge. All right. We know that the positive charges need to balance out the negative charges, so it's going to have 20 electrons. And since it has an atomic mass of 40.08, we know that its mass number is 40 minus the number of protons, and that's going to give me 20 neutrons. So that is what we refer to as the calcium neutral atom. How is the ion different? How is that going to be different than what we've had here? Well, let's go to a calcium +2 ion. Now, a +2 ion or 2 plus ion still is going to have the same number of protons, which in this case is 20. It's still going to have the same number of neutrons, which again in this case is 20 as well. But because it has a +2 charge, that means that it's lost 2 electrons. So now the protons outnumber the electrons, and if calcium as a neutral atom had 20 electrons and we need to lose 2 electrons to get that +2 charge, that means that now I have 18 electrons. So in a +2 charge or any positive charge of an ion, your cation, that means that you're losing electrons, the protons outnumber the electrons, and you're going to get a different number. Now, let's go back and look at a chlorine ion. We look at chlorine here, which has a symbol of Cl, and if we go and look on our periodic table, and we'll see that chlorine has an atomic number of 17, so that means it's going to have 17 protons. All right. We know that chlorine as a neutral atom means that electrons are going to equal the protons, so we have 17 electrons. And we know chlorine has a mass number of 35, so that means it's going to have 18 neutrons. So this is our chlorine neutral atom. Now, let's go back. Let's look at chlorine as an ion. So we have a chlorine, which is a -1 charge. It's still going to have the same number of protons as the neutral atom, 7 protons, which is a plus charge here. We're still going to have 18 neutrons, but now we have a -1 charge, which means we've gained electrons. We're going to have more electrons than protons, and that means we're also going to have 18 electrons. So again, the differences in our charges here, that means that we're changing the charge by adding or removing electrons. Please remember, do not change the number of protons. You're going to change the element if you did that. So moving on here, it is our favorite time of the notes. It's our brain break time, so why don't we get up from our desk? Why don't we move around? Maybe we'll do a few sit-ups. Maybe we'll do a few one-arm push-ups here. And today's Chuck Norris fact of the day, football season for all of us. Peyton Manning can throw a football over 50 yards. Chuck Norris can throw Peyton Manning even further. Alright, so we're going to move on from here and get into our next type of atom, and we're looking at an isotope here. Now, ions had a difference in charge. With an isotope, it's a variation of the same element or atom that we have. Now, with isotopes, it's still going to have the same number of protons and electrons as it does for neutral atoms. But in an isotope, we're going to have a different number of neutrons in the nucleus. In fact, a lot of elements have multiple isotopes that exist in nature, and the only difference is the difference in the number of neutrons. But when you change the number of neutrons, you get a change in the atomic mass, and the way that we indicate that is either the name with the symbol or its name symbol with the mass number of that particular isotope. So you will see here we have carbon 14, which means that its mass number is 14. Now if you look on your periodic table, carbon normally has a mass number of 12. Well, this carbon 14 tells me this is an isotope, and this is the mass number that I'm going to use to determine my structure. With the symbol, you're going to see it on the left-hand side, superscript again with the mass number. So why don't we go back and again take a look here. You have a blank space to look at the isotopes here and be able to give an example. So if we look at carbon here again, we know that the structure of carbon as a neutral atom is going to have 6 protons. It's going to have 6 electrons because the protons need to equal the electrons and protons. And we're going to have 6 neutrons. But as the carbon-14 isotope, and I know it's an isotope here because its mass number is different than what's on the periodic table. It's still going to have 6 protons. It's still going to have 6 electrons. But now, as far as my neutrons go, I still find it the same way as I do with a neutral atom. But instead of using the mass number that's on the periodic table, I'm going to use the mass number that's given to me here, which is 14. So if I take 14 minus my number of protons, which is 6, that is going to give me 8 neutrons. So now we have a difference in mass because of a difference in neutrons. And we'll learn a little bit more about atomic mass and mass number of isotopes a little later on in our lecture. So I hope you got a little more information out of here. Again, make sure you're taking a look at some of the examples that are given on some of the web links that we have, as well as some of the informational videos that you have. And please, again, if you have any questions, please make sure you ask.